How are you all today? Yeah? Everybody doing good? Are you having a good time at Trailhead? Yeah? Awesome. My name is Ian Varley, and I am here today to talk to you and give you an insider view of the Salesforce architecture. This is the real shizzle, y'all. This is where we're going to have the real talk about what's going on under the covers to make Salesforce go. Y'all ready? Y'all psyched? Yeah? All right, good. Okay, so I'd like to let you know about some forward-looking statements that I'll be making. You've seen this about 300 times today already, I'm sure, but don't make any purchasing decisions based on what I'm going to say, and I mean that quite seriously. Okay, so who am I? My name is Ian Varley, and I'm a software architect at Salesforce. I've been at Salesforce for about 7 years, and my team is called Architecture Strategy. Our goal is to clarify and simplify the architecture of Salesforce. Nice, simple goal, much harder than it sounds. I live in Austin, Texas. Anybody here from Austin, Texas? Anybody? Yeah, Austin represent. What's up? It's a balmy 300 degrees in Austin today, so I'm glad to be here. And this is me on Twitter, the Future Ian, or the Futurian, depending on how you pronounce it. All right. So what is our topic today? Our topic is everything. Not really everything, but everything related to architecture. I'm going to try in 30 short minutes, which I think maybe I get a couple extra minutes because the timer hasn't started yet. Woohoo! Oh, I started it. Oh well. Okay, in 30 short minutes, 29 minutes and 54 seconds, I'm going to give you a top-to-bottom view of what makes Salesforce tick. So I'm going to cover just some basics real quick to make sure we're all on the same page to start with. Then I'm going to talk about the overall system architecture. I'm going to talk about the kernel of the Salesforce CRM core application. I'm going to talk about the way the data is structured. This is a lot to cover in 30 minutes, and I apologize because this is going to be a little bit like drinking from a fire hose, and I'm sorry about that, but such is life. But I will say, if you have questions that remain unanswered at the end of my talk, I would love for you to come and talk to me right afterwards, or we can go get coffee. I want to hear what you have to say, and I would like you to ask me really hard questions. Cool? Yeah? Yeah? Good. Okay, let's start with the basics. As you may have heard here and there, trust is probably the most important thing that we do as a company because you're entrusting us with really important data. And so everything we do the paramount thing we think about is the security, the availability, the correctness of your data and the systems that you use on Salesforce. So that's like the number one thing we worry about, right? But, and it's a big but, we also operate at web scale, right? We operate at a very large scale, billions and billions of transactions every single day. So the unique thing that Salesforce does in the industry is the combination of those two things, right? Enterprise trust at web scale, right? That's our mission, and that's everything in this architecture that you're going to see supports enterprise trust at web scale. So the basic premise of Salesforce, as you've heard 100 times, software as a service, we run it, you use it, isn't that wonderful? Now, technically speaking, that's a lot more important to you than you might realize, because that means all of the dumb stuff about software maintenance, we do it, right? So database upgrades and capacity and troubleshooting, right? I sometimes joke that our slogan is, Salesforce, we work with Oracle support, so you don't have to. Just kidding, Oracle. Okay, so the other big concept in Salesforce world is multi-tenancy. Now, you might be familiar with web applications that are where you have personal data online, like your banking system. And you're probably also familiar with web-based systems where everybody shares common data, like Wikipedia or social networks. Multi-tenancy is like somewhere right in the middle, right? Where you have groups of users who share data with each other, but not other groups of users. So that's like your company. Everybody in your company is working on a shared pool of data, but never the twain shall meet with other pools of data from other companies. And that's extremely important. That's the most critical security boundary within the system. Your data, while it is, while it shares hardware and shares software with other tenants, right, running at the same time, that software has to keep all that stuff separate from tenant to tenant. So that's fundamental importance. Okay, so I just wanted, that's the basics, and I just wanted to kind of make sure we're all on the same page. Are we all on the same page? Show of hands? Yeah? Oh, right. Awesome. Okay, so let's talk about the system from a very high-level perspective. So you can think of Salesforce as one massive distributed system. We're going to start from the bottom up, but think about this as a sort of a guided tour of the various levels of scale of Salesforce. So starting at the very bottom, I already talked about tenants, right? You're inside of a tenant. It's a logical construct. But then outside of that, that tenant, when you work with it and make requests to it, those requests are running in multiple different services, application services, data storage services. I'm going to talk about this a little bit more. But then those services are then grouped into instances. And I say sharded here, and I'll explain what I mean by that. But basically, those services are all in these independent instances. And then there's these groups of these instances, which we call properties, which are architecturally diverse parts of Salesforce. Like Heroku is architecturally diverse from Salesforce core, right? So you've got tenants inside of that use services, which are inside of instances, which are inside of properties, all of which run in real physical data centers that are spread on many, many thousands of servers all over the world to make this one big product that is distributed around the entire globe. So that's a fairly complicated thing to manage. Inside of a single tenant, I already talked about tenants, so I won't talk about this too much. But basically, the way we logically separate that data is using identifiers. So it's not on separate VMs. It's not on separate hardware. The tenants just use different identifiers, but they're stored in the same database tables, running on the same servers in the same processes, side by side with each other, right? Now, I mentioned services. We have a lot of services. Now, you might say, is this a microservices architecture? Maybe. We do have a lot of services. We like to think of it a little bit more like a mesoservice architecture. Steve Tam came up with that word. And I'll explain a little bit more about what I mean by that. But yes, there are a lot of different software services, physically running daemons on servers, in containers, and on physical hardware, running in our data centers that do things like data storage, run business logic, and do caching and search indexing, store big blobs of data and files, do file conversion type processes from PDFs to other kinds of data and things like that. And then on top of that, we also have services for machine learning and queuing and event subscription and feature flags and basically tons and tons of different discrete software services, which is great, okay? And there's a lot of these. Now, and I should note, when I say service, I don't mean one process running on one server. Typically, most of these services are actually little fleets of services behind a load balancer or in a cluster or something like that, okay? So now there's two special services that I'm going to come back to in a minute, okay? So hold your horses. But those are kind of the underpinning of the Sales Cloud, Service Cloud, Communities Cloud, and Platform Clouds. And this is the application server and the database server. I will come back to those, I promise. But those are sort of the special big ones. Now, the services are grouped into instances. What are instances? Instances are essentially separate sets, stacks of hardware, right? So database servers, application servers, et cetera, right? We have a bunch of those, topping 100 at this point, just within the CRM core stack alone. And the main reason we do instances, there's a few reasons. The main one is for scaling, right? We like to be able to scale out. And since tenants are logically separate, we can shard them into different instances. And that's wonderful, right? It's good for us and it works for everybody, right? We also do it for fault isolation. So if there is some kind of hardware problem or something that isn't handled by the software, the blast radius of that is smaller, right? We also do it for geographic latency. So for example, for our customers in Japan, the instance that serves them is in Japan, so that their ping time is a lot shorter, okay? So there's a bunch of reasons why we do that. Now, outside of that, of course, we also have, as I mentioned, properties. So there's Salesforce has grown in a variety of ways. It's grown organically over the years. It's also grown via acquisition. And so we have different stacks for different kinds of purposes. And mainly what this does is it allows us to make different kinds of architectural trade-offs regarding things like data caching and graceful degradation and things that might legitimately really need to work differently for one type of application than for another. Okay, so you can see a few of the, if you go to trust.salesforce.com, you can see there's a few of the different properties we've got, right? So, trust.pardot.com and trust.marketingcloud.com and so forth. So this is an indication you can see those different deep level architectural stacks or properties. Now, you're probably sitting here thinking, okay, but this is all pretty abstract. Let's get into some real details about CRM and core and how it actually works. Cool. Let's talk about the kernel. So I'm going to be talking specifically, as I said, in this next couple sections about what we call CRM core. That is Sales Cloud, Service Cloud, Marketing Cloud, not Marketing Cloud, Communities Cloud, and the Force.com platform. Okay? So I mentioned the two big services. One of them is the relational database. So if you think about it like two bodies in orbit, the relational database is the core of each of our instances, like NA1, NA2, NA3. That's a relational database that is running as kind of the center of gravity with lots of other services that connect to it and sort of depend on it as their primary system of record. Then we have a whole bunch of application servers of different types that you might say orbit this one database, right, in a relationship with it. Now, there are dozens of other services that interact with these too, as I already said. But these two are the ones I'm going to kind of deep dive into for the next few minutes. So one is the kernel. So the kernel gives us a few things, including an application container, access control, product defense, a few other things. And I'm going to talk about these specifically. So let's talk about the application container. So that's when you make a request, an API request or a UI request to Salesforce, right? That's going to travel over the internet, and it's going to arrive at Salesforce at the front door, and then a bunch of stuff has to happen, right? So when it gets to us, it hits a stateless pool of application servers. Stateless means these servers are essentially, it doesn't matter if we lose one or another of these particular servers. There's nothing physically stored of your data on these servers. So if something's malfunctioning with one of them, we can just walk up and shoot it in the head, and everything's fine. All the traffic just moves over to another server. This is wonderful. This is a very important property in application servers for them to be stateless. And it's fronted by a load balancer, so that if one server is not behaving well, is a little bit slow, the load balancer can redistribute that traffic to the other servers, and everything's fine. Okay. Now on this server, it runs a piece of open source software called Jetty, which is a servlet container, and that is essentially the router that allows us to say, okay, based on what URL you're requesting or what your API request was, what piece of actual code should be handling this, right? So if you said, I want to update a record, well, it can send it over to the code that does record updates. And if you say, I want to render a report, it can send it to that code. So it's essentially a big router. It handles a few other things as well, but that's kind of the main thing that Jetty does for us. And then within this, there's a whole bunch of other systems that live in here for things like configuration and logging and debugging, kind of all live within this application container. I'm going to skip the login flow thing for sake of time, but that's the basic function here, right? The request path from I want something out of Salesforce to what do I get back, okay? That's what the application container, its job is, okay? Now, there's another important function within this kernel, which is access control. I already mentioned tenants, right? Tenant is the boundary for data. But you probably know, inside of that boundary, there's a ton of other access control as well, right? Internal to the tenant. So for example, you can set permissions on who can actually create records or delete records in individual objects. You can set field level permissions. You can set row level sharing with lots of complex hierarchies. This is a pretty complex subject, but this is all handled by the application container, right? By this application server code. Which is great. Some of the complexity here is such that if you can imagine, there's facilities within Salesforce where you can say, okay, well, you can see this record if you're my boss, or if you report to me, or if you report to someone who reports to me, or if you're in the division that this has been shared with, or there's like lots of ways you can actually get access to data, and calculating that on the fly all the time. Very, very expensive to do from a data access perspective. So actually, we materialize a lot of that stuff. When data changes, at the time that it changes, we say, OK, we're going to actually spawn out a representation of who can access what at this time. Like a lot of things in engineering, that's a trade-off, right? We're trading off some space, the amount of space that it takes to store this, and we're trading off some time when data changes in exchange for much faster access when you want to see who can see what. All right. Now I want to talk a lot about product defense. Product defense and security is extremely... Oh, I'm sorry. Actually, I can't talk about this. We do a ton inside the product to secure your data, and I am not going to tell you about any of it because this is a very public forum. But if you have questions about our product defense from things like malware or various other types of attacks, I'd love to talk to you about that one-on-one. So please come and talk to me about it afterwards. But it does involve Pop-Tarts. OK. Now, next I want to talk to you about a thing called the UUID. Has anyone here ever actually heard of the UUID? One? Nobody? Oh, awesome. This is like fresh meat. All right. So the UUID stands for Universal Data Dictionary. And what the UUID is essentially an abstraction inside this application server that allows us, our engineering teams, and you to define the metadata shape of your world in Salesforce, to create objects, to create attributes, field types, all of the stuff that you need to do as far as defining your business in Salesforce all happens in this layer. Okay? It is a declarative entity model. Declarative. What that means is the shape of this data isn't like a bunch of lines of code. It's in a format that just says this is the this is the name of the entity. These are the names of the attributes, right? And it's checked into source control when we do it, or it's stored in the database when you do it. But that's a very important point, that it's a declarative entity model, right? And what that means is it allows the same interactions on internal and external platform developers. So when you're writing and creating entities, and we're writing and creating entities that are shared across all organizations or all tenants, by and large, it is the same set of facilities that you have for modeling data and for working with data, right? So that's actually a pretty important shared abstraction, and that's a big part of the power of the platform, the fact that you can do that. Okay. So now internally, it didn't always used to be like that. Internally, when Salesforce was started, well, it was a sales tool. A lot of this platform stuff came along a little bit later. And so what they did when they started the company was they said, okay, well, we've got an account object and we've got a contacts object, and so let's just make an accounts table and a contacts table in our database. And doesn't that sound nice? And so they did that. And then for a number of years, a large number of years, by and large, when internal Salesforce engineers wanted to create something that every tenant would share, it became a physical table in the database. Now, meanwhile, we also have the ability to create custom objects, right? Objects that you define and create. And of course, that doesn't actually work as creating tables in the physical database for a variety of reasons that I'll talk about a little bit later. And so the declarative access model, the declarative definition model, is what allows those two things to coexist. Now, after a while, we were like, we have this wonderful custom object stuff that our tenants can use. Why are we still creating physical tables for the stuff that we're doing? So Mr. Stephen Tam, who's standing in the back here, wrote a few nice extensions that allowed internal engineers to basically do the same things that customers do. So this is actually a case where the facilities that you had as customers for building on the platform were a lot easier for a long time than they were for internal engineers. But we eventually got that parity, and so now we have this thing called base platform objects, which is what does that. Now, in addition, at runtime, when you're actually serving data, the UID is what functions as essentially an object relational mapping layer, right, between the data that's down there at the database level and what you see materialized in your org, okay? But, and this is a key point, what's actually in the database looks very little like what you see coming out. So you're used to going to a database and saying select star from some table, and then that's what's actually in the table. That's not how Salesforce works, right? Because of this metadata layer, all of that is virtualized, right? And I'll talk a little bit more about that when I talk about the database, but essentially, if you were to go and look directly at the database layer, it would be, without this application server as the intermediary, it would be useless to you. You'd have a lot of work to do to get it to work for you. And so the analogy that I make is it's a little bit like going to the gas station and trying to pump crude oil into your engine. Like that's essentially what you'd be getting. So now, a brief aside. Is anybody here familiar with Salesforce IDs, the 15-character IDs? Do you know that there's some structure inside of these IDs? Not everybody knows this, so I like to just put a point on it. So there's a few different parts of this. So the first three characters are what we call the key prefix. The key prefix is what identifies which entity, right? So if you were working in a standard relational database, that'd be like which table or which object, right? Which entity in Salesforce is this? And that's a 3-character identifier that's specific to your organization, your tenant, right? The next bit is which instance. Remember how I said there's these 100 different instances that are these groups of services? Which one are you on? Now, this is a bit of a trick here, because this doesn't actually mean which one are you on. It means which one was this record created on, because your tenant can actually move from instance to instance, right? This happens during instance refreshes, it happens during org migrations, various other things, right? And so why is this there if it's not actually telling you which instance you're really on? The reason is for uniqueness, right? If this weren't there, there would always be a possibility of ID collisions of IDs created on one instance versus IDs created on another instance, and we'd never be able to move those two organizations to sit on the same instance. So this is just a thing that makes sure that no two records are ever created the same, right, with the same ID. So that's very important. Now, the next 2 bits are reserved, and the reason that they're reserved, it's really good that we have reserved bits, and the reason for this, or characters, I mean, originally there were 3 reserved characters, right? And this is a fun story. There were 3 reserved characters and only 1 character instance ID, right? Now, and any of these slots here can be filled by a letter, lowercase or uppercase, or a number, right? So that means there's 62 possible, characters that can go in any one of these slots. So what that meant is in the original design, we only had room for 62 instances because that was the 1 character instance ID. And when we got to about 30 or 40 instances, we were like, oh, that's not good. But thank God we reserved characters there in that part of the ID. So we were able to change the code to use 2 instances for the character ID. So now there are 62 squared, right, possible instances. Now when we get to 3,844 instances, we're going to be in trouble again, but we still have more reserved characters, so don't worry, it's OK. And then the next part, of course, is the unique part of the ID, right, which is 62 to the 8th power. So there's plenty of those to go around. Now here's a pop quiz for you. Does anybody know why sometimes Salesforce IDs are actually 18 characters and not 15 characters? Why? Yes, it's right. There are some cases on the internet with the API and various other things on the internet that are not going to preserve case specificity. But as I already said, these are case-specific IDs. So what would happen if you take this ID with a bunch of uppercase and lowercase numbers and change it all to lowercase? It's a different ID, right? That's bad. That's what we call bad. So what we did was we threw on 3 extra characters, which are a checksum of the rest of the case of all of the other characters in the ID, right? So by using that, you can actually say, I don't care what case they showed up in, I know what case they're supposed to be. So it's a case checksum. So that's why you'll sometimes see 18. But you can always convert from an 18 to a 15 and back, and vice versa, as long as you know the case of the 15. All right, good job, good job. OK, so now we only have a few minutes left here, so I'm gonna go kind of lightning speed here. But let's talk about the database. So as I said, right, Salesforce models a virtual database on top of a physical database, which is kind of cool, right? And it does a lot of the same stuff that a physical database does, right? It gives you a rich model of entities and attributes and relationships and all that kind of stuff. So when you work with the UI and the API, that's what you see, all right? And this is entirely not true. It's a fiction. None of this really exists at the database level. It's not a fiction, but none of this is really physically manifested at the database level, okay? So when you create an entity, it does not actually do any DDL, if you're familiar with DDL, data definition language. It doesn't create physical structures in our relational database. What it does is it actually inserts a few rows and a few tables, and then the system behaves as if there's a whole new entity there, right? Now, why is that? Why did we make that decision? Because generally speaking, in a relational database, when you do DDL, when you change the definition of a table, like add a column or delete a column, it locks that table while you're doing that, which is fine if you're the only one using the database, but this is an online system, right? This is all over the internet, and we don't want to take any downtime when the admin in your org adds a new field to a thing. We don't want to lock the whole thing for 10 minutes while it updates the whole thing. So that's why it's all virtual. Okay. Now, interestingly, there's a lot of good and a lot of difficult stuff that comes along with that decision to make a completely virtualized database, right? So things that you would expect to happen just normally in a database, like for example, like foreign keys, we can't use those, right? Or unique indexes, we can't use those because everything in the database is actually this virtualized thing. And so all the stuff about how a database works, you have to just throw out the window. Or actually more specifically, we had to recreate all of that stuff. So we do have unique indexes, we do have foreign keys, but they're all enforced at the software level, not by the database. Now that's got some good points. It means we have more database portability. So we use one particular database substrate for a lot of our instances, but we can and should and maybe will port to multiple databases. And we can do that all because we don't really use this level of database stuff. This is all in our software. So that's wonderful, right? But now that also goes for indexes and a whole bunch of other stuff, right? So lots of fun for us as software engineers. Very interesting, hard, challenging problems as software engineers. Okay, but as I said, under the covers, it is in fact a bona fide relational database. Okay, so how do we actually do that? at the scale that we do, any given one of our, so we run most of it on Oracle, and most of what we, like as a general rule, each of our Oracle instances is running in the neighborhood of a few thousand tenants, okay, simultaneously, which is a pretty heavy workload to be asking for one physical database to do. We do a bajillion tricks to make that work, a bajillion. That's a technical term. So multi-level partitioning is one. So we actually have partitioning within the database instance itself onto multiple physical servers with a storage backend. Within that, we have partitioning on multiple physical files on disk, right? And a mapping between tenants and physical files, and they have affinity to a certain node for caching and a whole bunch of things like that, right? So lots of physical nodes, and then there's this, this sort of mapping between them. And then each application server actually has a pool of database connections that are going over to the application server. And we do a ton of tricks to actually make this work in practice. And so, for example, we have actually created our very own database optimizer, right? So you know how databases internally, when you send the SQL query to a database, it has an optimizer to figure out how should I physically execute that query plan. Well, when we use our actual database query planner, it just gives us garbage because this is a multi-tenant system, and it doesn't know anything about what's actually happening there. So we write our own query plans, and we enforce them using database-level hints, right? We also have a thing called skinny tables, which is essentially taking one dimension of a table and spawning it out for faster index performance. All of this, thankfully, is mostly invisible to you, right? And that's part of the whole deal here. That's part of why you're a Salesforce customer, why you get the power of developing stuff on top of this platform without having to be on the phone to Oracle support every day like we are. This level of indirection is invisible to you, and that's super, super important. So one last thing that I'll mention that I think is probably interesting is one way that the underlying database actually does kind of shine through in a way that you can see it is with database transactions. Is anybody familiar with what a transaction is at the database level? A few people? A transaction basically means I can do multiple kinds of work in this database, and then I can atomically commit or roll those back together, right? So I can say, take $1,000 out of this account and put $1,000 into that account, and it's either both going to complete or neither going to complete. Now, this is a facility that relational databases have had for decades, and it's super important because if you don't have that, all the people who build applications on top of your platform have to worry about that, right? They have to worry, what if it failed after I took the money out of here, but before I put the money in there? And if you have a multi-step process, you got to think about that with every permutation of those steps. Relational databases solve that with transactions. And it turns out that when you use transactions in Apex, for example, right, when you do multiple things within a piece of Apex code, those are transactionally protected at the database level, right? Which is wonderful. That means you can actually say, I'm going to mutate a few records over here and a few records over there. And if you're doing that within Apex code, since it's all running within the same transaction at the application server level, then you get that database transactionality for free, which is wonderful. It's also a bit of a challenge for us because it requires co-location of certain kinds of services that we would probably rather be able to split into different micro or meso services. But that's our problem, not yours. So if you like this and you would like to see more, I would like to inform you that this entire presentation has actually just been an advertisement for my blog series on Medium. So I write a series called The Architecture Files on Medium. And you can read about all these topics and many more if you subscribe and go and heart all of my articles. We've talked about sharding. We've talked about event publication architectures. The database is a magician is a favorite of mine. Lots of video game references. So a lot of the stuff we've talked about here, if you kind of got what I was talking about, but not maybe 100%, go check it out on here, and I bet you will have a better experience and a deeper understanding. And follow, because we'll be continuing to publish. OK, so as I said, I don't think we have time for questions like mic questions or anything like that. But I'm going to step on the stage right over here, and I would love for you to mob me, and we can go get coffee. We can talk about whatever you want. So please come see me, and thanks for your time.